So today we'll be covering administration and maintenance. As part of that, we will be covering name node and data node directory structures and files. So what are all the directories which will be used by name node as well as data node, and what files it will write. So what is the meaning of those files, and we will go in detail about file system image and edit log. These are the two uh, 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 components which will be used by name node, or these are the two type of files which will be used by name node. And then we will understand name node high availability or name node failover conditions. Then we'll also see how to add new nodes to the cluster and remove nodes from the cluster. And the final topic in this administration and maintenance part will be Hadoop file system recovery. So if some of the files got corrupted, how can you recover those files? Okay, and after that we will see monitoring and troubleshooting the cluster using logs or stack traces. How can you troubleshoot your cluster? Also we will see how to monitor the cluster, so the current state of the cluster, and how can we create alerts out of that so that somebody else can look into those problems. And finally we will be looking at job scheduler. So what is job scheduler, how many types of job schedulers are there, and how can we use capacity scheduler as well as fair scheduler. Okay, so these are the topics for today. So first we will go into administration and maintenance. So before going into FS image, I'll tell you a few things. Okay, so yesterday we have looked at HDFS site.xml, inside which we have looked at Hadoop's.temp.dir property. So we said like that is the base directory in which actually other entities like data node and name node as well as the secondary name node will create the directory structures, and they will write their information into those directory structures as files. So today we will understand those directories and files in depth so that we know actually what is going behind the scenes. So first a component in that is name node. So name node will create a directory inside the base directory as dfs/name. Okay, so so we will see what are all different files and folders it will create inside dfs/name. Okay, so name here stands for name node. So this is the directory in which the name node will keep its files. So when you say name node is keeping its files, means actually these files are having the metadata information of the data which is present in the cluster. Okay, so these are the mappings which will be maintained by name node to tell what blocks are residing at on which node, and which all blocks can make up a file, or what is the file means in terms of blocks. So this information, this metadata will be stored inside these directories. Okay, so for you can just go and say ls and you can see all these directories. To understand better, I just have created it as a tree structure. So inside the DFS node, so we have current directory and we have a file called version. Along with version we also have scene underscore txid, just transaction ID, and along with the current folder we have in underscore use.log. So inside DFS name, so you have one folder and one file. One folder is current and one file is in underscore use.log. Okay, and inside the current you have four types of files. One is version file, one is scene underscore txid file, one is edits file, and one is fs image file. Okay, so let us understand in depth about these files. So first we will go and see where these files are located. When you are training VM, so you can go to /var lib Hadoop HDFS cache HDFS. So this is the base directory you have, and here if you say ls, this has DFS, and inside which you can see data as one folder, name as one folder, name secondary as one folder. So these I mean folder and directory are synonyms. So these directories, each directory is corresponding to one component, because we have all the components running on the same node. It's a single node machine or single node cluster. So we have three folders inside this directory. One is data, one is name, and one is name secondary. So first we are going to understand the directory of name, because we are going to understand the name node directory structure and files. So let us go into name and say ls. So if you see, it has two files, one folder and a file, or one directory and a file. So the directory name is called as current, and the file is in use dot lock. Okay, so the in use in lock is the file which is used by the name node to tell that I am using this particular directory, or I am using this particular location. So other name nodes, if we start another name node on the same machine, they will not come and use the same location. So there will not be two people concurrently modifying the data, and there will not be any corruption. So if the in use dot log file is there, that means actually another name node will not start on this machine with the same directory. Okay, so it cannot start, because it first checks for whether this file is there or not. Okay, so that's the use of in use dot log file. Okay, then if you go into current directory, so there will be lot of files. So first file will be version. Okay, now let us cat this version and see. Okay, so this version has some information, name node, namespace ID, cluster ID, and block pool ID. Okay, so this is your namespace ID, this is your cluster ID, and this is your block pool ID. Okay, I hope everyone knows CD, ls, and cat. I mean, those are CD is to change directory to go into the directory, ls is to list the files and directories, and cat is to show the text. Okay, it's like open that file and show me the text. So I'm just seeing the version file. Inside that version file I can see this information. So out of which actually the IDs, namespace ID, cluster ID, and block pool ID are unique across the cluster. Okay, so these will prevent data nodes from registering accidentally. Okay, because actually this information is there in with inside the version file. And you have storage type. So storage type here is name node, because this we are in the folder of name node. Okay, which means actually this particular directory is being used by name node component. So storage type will be name node. In case of other folders, we will see that will be different file. Okay, and C time is the creation time of the file system state. So we have created, we have not reformatted it or something actually. So C time is 1, and layout version tells that what is the change which happened with respect to the layout of the data. So if you are changing the layout, the Hadoop development guys change it and give you a new version, then your layout will be in the older version and your Hadoop version will be newer version. And if it is backward compatible, then your data will work. Otherwise they will give some tools to convert your data to the newer layout. Or otherwise, if your data is newer and you have changed your software to the older version, then it won't work, because the older version doesn't understand the newer layout. So then that shows you that you have to go to the newer version, you have to upgrade your software. So that will tell you about that, but that's very internal. Like you can see about this layout version and all in the release notes, and then you can understand. But otherwise, we don't understand what is this -40 or something, right? So that is about the version file and in use log file. Okay. So next file is your edits file. Okay. So you have edits file I'll just say ls. Okay, so you have edits file and you have fs image file. There are two types of files, and one is scene underscore transaction ID. So let us understand what is edits file and what is fs image files. So if you see, there are so many edits files and there are so many fs image files. Okay, so we'll go back and understand what is edits file and what is fs image file. So fs image, so what will happen is there will be a lot of clients who will be coming to your cluster and they will be telling that I want to write a file, okay, or I want to modify a file, so, or I want to read a file. So whenever you get a request from the cluster, from a client to the cluster, they will come to the name node. If it is related to file system, they should come to the name node. And when they come, so your name node should remember what that guy is doing, what the client is doing in terms of writes, modifies and all, essentially, especially. So it will say that, okay, now he has written a new block and he has written a new file, and that file has 3 blocks, and these 3 blocks are, I'm putting it on 3 different machines, and later I'm also replicating something like that, right? So all that information has to be stored inside your name node. So that information will be stored inside this file called fs image. So fs image means actually file system image, right? So it will be having the metadata of all the blocks. So those will be created whenever there is a call from the client, whenever client is coming and then asking to do. So the first thing what name node will do is it will remember that inside fs image. So every transaction, so all these requests which are coming from the client will be called as transactions. So every transaction will have a unique ID which will keep on increasing. So that is called as transaction ID. So that transaction ID will be stored, and the actual transaction is also stored inside the fs image. Okay, so that's the fs image file. So if you lose fs image file, then it is like losing whole data inside your cluster, because without metadata all the data inside your cluster becomes useless, meaningless. Okay, so fs image is a very important file. So going ahead, we'll also understand how to do name node failover, because if you lose fs image, you are going to lose the complete cluster. Okay, so that is about fs image file. Then the second type of file, if you see here, it's not just fs image, it also has edits. Okay, so edits is another file you have, another type of file. So this is the file which actually stores all the transactions. Okay, so what will happen is whenever there is a change, that change will not be directly saved by the fs image. First it will be logged in edits file, and after that fs image will apply these edits on top of its image, on top of its fs image. Okay, so it is something like that. If you have a bank account, okay, and bank account has 500 rupees or $500 inside that, so that's the state which is there on the fs image. And if you are going to withdraw some money like $50 or 50 rupees, so that information first will be stored on edits, and then that will be applied on fs image. I mean, we will understand why it has to be done in that fashion when we understand name node HA, but for now you have to remember that first they will come into edits, and then they will go into the, they will be applied to the fs image. Okay, so so the third process, the third point we have to understand is actually checkpoint. So checkpoint is a process which will apply these edits onto fs image, because fs image is a file, edits is a file. So checkpoint is the process which automatically triggers based on the policies configured on your HDFS, or you can also manually trigger the HDFS, but we will not be doing it. It will be done by the administrators specially. So mostly it will be run automatically by the policies, and whenever it runs, actually what it will do is it will go and check. So if you see this last file is scene underscore transaction ID, so it will go and see the scene underscore transaction ID. So scene underscore transaction ID is not the final transaction ID. Okay, so if you are at the transaction 1000, it doesn't store 1000. Okay, what it will store is, it will store the transaction which is completely applied on top of FS image. So if your FS image is at transaction 800 and edit logs has 800 to 1000 transactions not applied inside that, so your scene transaction ID will be 800 only. So checkpoint process will first see this scene transaction. Okay, it says okay till 800 FS image has the data. Now the other whatever the new edits are there on the file, so that I have to apply to the FS image. Now it will queue that and it will keep on applying, and whenever it applies, it will go and update the scene underscore what is that file, scene underscore transaction ID. Okay, so that is what it will do. So those are the files which are there in the name node. So I'll repeat what are all the files we have in the name node. So the first file we have is in_use.lock, so which tells that this particular directory is being used actively by a name node. So if other name nodes tries to use this directory, because of the code which is written in the name node, it won't start. The name node won't start if you give the same directory. So so that means actually it will stop the concurrent writes onto the same location, so that there will not be any corruption into your data, your metadata. So there will be one more directory called current along with in_use.lock at the same level. So inside the current directory you have four files. One is version. Okay, version has your namespace ID, cluster ID and block pool ID, which are like unique. And you have storage type, which says whether this is a name node or data node or journal node. And this will also tell ctime ID, ctime, which tells when this was actually created. Ctime means creation time. And layout version. Okay, so layout version tells what kind of layout it is using for writing this metadata. Okay, so what is the version of the data structures that is being used inside this name node. And so then there are two types of other files. One is edits files and one is FS image. So FS image will be a file which contains the complete state of file system at a given point of time. Okay, so that will not be the current state, that is a state at some point of the time, and what till which transaction ID it has completed, you can see in the scene_transaction ID. And edits will have all the transactions which are there, which are happened on the system, on the cluster. So checkpointing is a process which comes and applies these edits from scene transaction ID till end to the FS image to make FS image complete. Okay, so that is about the files inside name node. So name node is having all the information in its memory. Okay, so information is always up to date. So what we are talking about is putting the same information on the disk also, so that actually when name node dies because of any reason and we restart the machine or we restart the process, still the information is available to the name node. So name node not only puts the metadata inside its memory, but also it will write it into the edits and FS image. Okay, so we are talking about the secondary storage essentially, right? So name node has the correct information at all point of time in memory. So whenever name node does something, it will also update the edits log. Okay, so updating edits log is easier than applying on the FS image. So that's why it keeps on writing into the edit logs, and whenever it has some free time, name node, it starts. Okay, so that actually the edits will be applied to the FS image. Also, when you are starting for the first time, or when you restart the name node, or it kills because of some issue and you start name node again, there also first checkpointing will start and then only your name node will start. Version is not a single information, it's actually a map, right, with key value paste, and it has lot of information. One of that information, like block pool ID, cluster ID and namespace ID are the three IDs which identify that you belong to which cluster and you belong to which pool. Okay, so actually you are uniquely identified inside the whole cluster. Yeah, that's an identification. And storage name says that if somebody actually, a data node comes and tries to do something inside this directory, it will see, okay, there is a version file. It will open that version file and see, okay, this is name nodes directory, so I'm not going to touch it and do that. So if you go into a name node, I mean name directory, we have seen all those different files, right? So let us go into data directory and see what are the files you have. So I'll go back. Okay, I am at this location. PW will show the present working directory. This is var lib Hadoop HDFS cache HDFS DFS. Inside that we can see there is name directory, which we have already seen. There is something called data directory. So if you go into data directory, okay, you should be HDFS user. So this particular command will first make me, sudo will make me as a root user, and su minus HDFS will log me into HDFS user. So I am going from trainer user to HDFS user, because HDFS user is the super user there. So I will go back to that directory. So this is the base directory. So PWD, so CD data. Okay, only if you are in this user, who am I, will tell which user you are currently, your current user. So I am using who am I, means who is the user right now. So it says HDFS. So my username is HDFS. So now I am inside the data directory, and if I say ls, ls will list the files. So this also has the same files, same directory structure. One is a directory called in current, and one is in underscore use.log. So if you are going to run another data node on this machine accidentally or knowingly for experimental sake, and if you are giving the same directory, it won't come and then corrupt this information, because first thing it will see is if this file is there. If this file is there, it won't use this. It will complain saying that this is already in use. So that is the use of this. Then inside the current directory, you can see there are two files. One folder and a file. So this folder is related to your block pools, and version will show the similar kind of information. So cat will show the text of the file. So when you have some n number of nodes, you have a 10 node cluster, and you want to actually remove some of the nodes. This actually we have already covered yesterday, but I'll just tell you how to do that. So we can remove some of the nodes, we can exclude some of the existing nodes. We can tell to the Hadoop saying that please don't use these machines for storing the new files or for running the yarn applications if you are using yarn, or MapReduce programs if you are using MapReduce. Right? Because you have a doubt on those machines are infected, or those machines are having some physical problems, you are actually looking into that and you don't want to use those machines. In that case, actually yesterday we told that you will use dfs.exclude property inside your hdfs site.xml. So you will create a file with comma separated these host names, and you will give that file location as a value for dfs.exclude in hdfs site.xml. if it has to be only excluded from dfs, and if it has to be also excluded from MapReduce, then you create a property called mapred.exclude in the mapred site.xml XML file, and you give the same file name in which actually you have host names, the host names of the files of the nodes which you have to remove, like exclude from the operation. And once you do that, you have to issue, no need to restart your services, you can issue a command called Hadoop DFS admin -refresh nodes. So what it will do is actually it will refresh itself by excluding these nodes. Okay, so for doing that you should be logged in as a HDFS user. Inside this, by default you will be trainer, training user. Okay, so what you have to do is sudo as a root, you are going to su minus hdfs is logging into hdfs user. So inside which you have to use Hadoop DFS admin hyphen refresh nodes. Okay, so this will DFS admin. So this will refresh the nodes. That's all. Because it's a single node, I am not changing anything and putting. But when you do the multi-node setup, after that you can try all these things. You can put one of the node into exclude list and change it. And if you want to exclude it from the yarn application also, running the yarn application, you have to change mapped-site XML. You have to add this property and value will be the file which has the exclude list. And after that, you should become a mapped user. So sudo is again the same thing. This will make me as mapped user. And inside that, you have to issue command yarn. Okay, rm admin. Rm means resource manager admin, and say refresh nodes. So this will refresh the nodes. But if you are using version v.1, now version v.1 is not supported on the installation whatever we have installed, but it used to be a command called with the same user mr admin. Okay, but now if you say mr admin, it says there is no such command for the Hadoop. Okay, but previously we used to do mr admin and then refresh nodes. Refresh nodes will actually refresh the in-memory details about the nodes for the Hadoop. If it is HDFS, it will refresh the nodes in name node, and for MapReduce or yarn, it will refresh the nodes inside your MapReduce framework. Okay, so that's what it will be doing. So to remove nodes, you have to use exclude file, and to add nodes, you have to add these nodes back. Okay, then you can use include. This is not to add new nodes into the cluster. This is like if you remove some of the nodes but you want to re-add that, then you use include. Okay, don't think that okay, if you add one node IP address to include and then put into that, then that node will be automatically added to the cluster. But that's different thing. Okay, here actually what I'm telling is if you want to re-add the removed nodes, you can use it. Because the difference between adding a fresh node versus removed nodes is removed nodes already has the installation, it has all the configuration file setup. Whereas if you are adding a new node, fresh node to the cluster, it's a completely different concept. That is not what actually we are talking here. And final concept in this section is how to recover the file system corrupts. If there is any file system corrupt happens inside your Hadoop file system, or if there is any corruption happened inside your metadata in name node. So if there is any corruption happens in metadata of your name node, you can use Hadoop name node hyphen recover. So what it will try is it will use some algorithm to recover it, but it can also delete all the data whatever you have if it thinks that everything got corrupted. So I mean, you should be very careful when you use name node recover, and you think like if that metadata is there on secondary name node, better go and make the secondary name node as primary by shutting down this name node and install a fresh or something for this name node, so that this becomes secondary from the next point. Okay, so that is about name node recovery. But if there is any problem in your file system, how to do that? For example, now let's do this. So I have Hadoop fs -ls/temp. In the previous class, I have copied some files like students1.txt and all, right? So if you see, actually this is like students1.txt. Let me see students5.txt. Okay, so students5.txt has a replication factor of 2. Okay, whereas I have only one node. So definitely there is a problem with this file because this doesn't have all the replicas. Okay, let us see if my FSCK give me that information. So FSCK will only give the information. FSCK stands for file system check. Okay, it will check the file system. So whatever the input directory you give, so you can say temp. So I have given temp directory. This temp directory is not my local file system temp directory. This is the temp directory which is there on Hadoop file system. So so what it is doing is actually it is checking and it is telling that temp admin.txt, which should be having 4 replicas, but it only have 1 replica. Okay, so FSCK will only check and tell you the problems. It will not repair it. Okay, if you want to repair that, you have to take a decision how to repair it. So either in this case, I know that because I only have 1 node, it can't be replicated for 4. So first thing what I can do is I can add more nodes to this cluster, so that my name node knows that there are more nodes and it will replicate itself. Or other way to do this is actually I will delete this file itself. Okay, if I don't need this file, and I can delete it. Okay, so for every problem there is different ways to solve that when you say FSCK, but FSCK will only report you the problems. In case of Linux, FSCK will actually correct the problems also, but in case of Hadoop, it won't correct the problems. It will only show the problems. Okay, so that is your file system recovery. Actually, either you can check the file system if there is any corruption on the HDFS, and you can check the correct metadata in name node using Hadoop name node -recover. So FSCK stands for file system check. So it will check the file system. So it has a set of rules. Based on those rules, it will see every file. If it is not matching, it will immediately say this is an anomaly and it will show the report. Okay. So administration should include monitoring and troubleshooting the cluster. Monitoring means actually we will be looking at the cluster and understanding if there is any anomaly, any difference in the behavior of the cluster, and if there is any, then going ahead and understanding what is the difference, who caused it, how can we solve that problem is about troubleshooting. Okay, so monitoring and troubleshooting will go hand in hand. So for monitoring, the biggest source for monitoring the cluster is logs. So you can use the log files which are written by different services or different components / different daemons which are running in the Hadoop. Like name node is a daemon which runs, data node is a daemon which runs on the Hadoop cluster. So you can individually go to these log files and can check the log files. So what is the problem? You can see some stack traces. If you are from Java background, you know what is stack trace. So it tells in the program where the problem is. So based on that, you can actually search on the net or open a ticket for the open source community to see if it's a unique problem, if it happens, if it is a bug, right? So all the logs by default are kept under /var/log /Hadoop hyphen, and after that hyphen actually it change. If it is HDFS log, it will be HDFS directory, and if it is yarn log, actually it will be /var/log /Hadoop hyphen yarn, and if it is MapReduce /var/log /Hadoop hyphen star. I mean, because of autocorrect, actually all these became capitals, but it will be small h, small y, and small MapReduce. Let us go and see in your training. Okay, so I can go to /var/log. Okay, inside this directory, there are like so many files, but you can see here there are these 3 directories. One is Hadoop -HDFS, Hadoop -MapReduce, and Hadoop -yarn. So if you can go into Hadoop -HDFS, you can see logs related to secondary name node, logs related to name node, and also logs related to data node. So these 3 are the different logs in HDFS, because these are the 3 different components which you have in HDFS. It can be name node, it can be secondary name node, or it can be data node. Okay, so you can see all these logs. So you can open these logs. VAM is like opening the log, opening a file, Hadoop hyphen data node hyphen okay, Hadoop dot log. So if you see, actually it has a lot of information in these logs. It says it is starting up and doing something. Okay, you can actually search for error or warning by scrolling this down, or you can use a slash in this VAM and say error. You can write it, so it will search for the error. Okay, it says this error says received signal sig term, which means actually somebody asked it to shut down. So that's not an error. That's okay. So, but sometimes you can see some errors, some stack traces after the error. Based on that, you can understand what is going wrong. If your data node is continuously crashing and all, you can actually copy paste that error and at least send it to the admin that this is happening if it is happening at your location. Or if you are admin, actually you can understand that stack trace and get a ready solution from the open source community. Okay, if it is already fixed. But if it is not fixed, you can open a bug for the community, which they will go ahead and solve it. Okay, so the this directory is actually var log Hadoop HDFS. But in the same way, actually you can say var log Hadoop MapReduce. Okay, so in this you can see the MapReduce logs. So you have history server. So let us go to yarn MapReduce history server dot Hadoop dot log. Okay, so this has all the information about history server. Okay, so you can see some stack trace here. It says error creating directory. It is not able to create some directory. So these kind of errors you can see at last if you go. So finally it was able to retry and then able to create the directories and files. If it is not able to create, actually it will shut down itself. So we can see the process and all. Okay. So to come out, actually when you say VAM, to come out you say escape colon Q. It's like quit from that file. So but this is the standard location. And if you want to change this location, instead of var log, you want to write somewhere else. So you can change that location using Hadoop underscore log log underscore dir. This is a variable which you can set in Hadoop env.sh. Right? If you remember, you have in etc Hadoop conf, you have Hadoop env.sh. Inside this, you have Hadoop mapped home. Similarly, you can say export Hadoop underscore log underscore dir equal to /opt/Hadoop /logs. So you can put like this. So if you do this, then all your logs will be created under that instead of var log, and after that the directory structure will be same. So it will be same as Hadoop hyphen MapReduce, Hadoop hyphen yarn, Hadoop hyphen HDFS. Okay, so you can change the log directory, because by default if you don't have much space on var, and if you want to put it into some other directory, you can put it into that directory. Okay, so the first way to understand or monitor your cluster is using logs. Okay, but you cannot keep on opening these logs and then looking at the stack traces and all. So what we can do is we can use tools like Nagios. So Nagios is a tool, open source tool. We are not going to install it and see, but just for understanding, Nagios is a open source tool. If you write some set of rules, like saying that if this particular log has this message like error, then you have to send a mail to these XYZ persons with that log file. Okay, you can write that kind of rules, and what Nagios will do is it will create alerts. Alerts means actually it will either send a mail or it will actually save files at some places and all. So it will create alerts based on your rules. It's not required for you to continuously look at these logs. Instead, this process will keep on looking at the logs, and if this finds any of these rules, then it will go ahead and send a mail to the admins. So admins can come back, admin can come back and look at the problem, and they can actually correct the problem. Okay, so that is the use of Nagios tool. So Nagios will be installed separately outside your cluster. So it's not a node on your cluster, it's separately outside of cluster. Normally admins will have Nagios for other alerts also apart from our cluster, Hadoop cluster. So they will only use the same Nagios for putting alerts on top of your Hadoop cluster also. So it's not like Nagios is only installed for your Hadoop because of Hadoop. It's not like that. Nagios will be normally there for most of the admins, admin teams, right? So second one is, if I want to understand the usage pattern of my CPU, my network, or my disk load, all these things, like how much memory I am using. So if you want to know that, one thing is you can do, you can go on to every node on your cluster, and you can use tools like Top. Top is a tool like in Linux, which will show the memory usage, your disk usage and all per process. Okay, so TOP is the tool. So you can use that kind of tools and then keep going to these nodes and seeing it, but that's not practically possible. If you have 500 node cluster, it's not possible. So you can use tools like Ganglia. So Ganglia is also open source tool, which actually has agents on all these machines, and it will keep on getting this information from all these machines, and it will be stored inside a small database which it has, and it will keep on showing it as a plot, like what I have shown as a screenshot on your on the slide, right? So it will keep on showing. So I can see that at 15, almost at 15:25, I can see a spike in the running process. Okay, I can go and go to the resource manager or job history and understand, okay, somebody might have actually created a job. If that is not the case, then I'll go and understand or debug what is the problem. Okay, why all of a sudden my running process increased? Is it because of somebody else? Something else is going on the system which is not required, right? Also, I can see the CPU shoot. So CPU shoot also happened here. Also, I can see there is a network shoot also happened here. So these kind of information we can gather from Ganglia. So Ganglia will keep on polling for this information from these nodes. It will ask for this information. Whenever it gets, it will store in the database and show it into different graphs. So we are not going to actually install all these things and see, but you will be able to at least understand the terminology when you hear about Nagios or Ganglia. So Nagios is specifically for alerts and Ganglia is specifically for metrics. The difference between alerts and metrics is, metrics is like keep on polling some information and then plotting that information as graphs or as different charts. Whereas alerts is polling for an rule to happen, and if that rule happens, actually it will send an alert. It will notify others. Alert means actually notifying others, saying that you have to actually look at the system now because there is an anomaly. There is a difference between what is expected and what is happening. So that's about tools to monitor. Okay. So now if you have YARN applications or MapReduce jobs, right? So we'll talk about YARN applications. So if there is a cluster in an organization and it has lots of data, and there are so many teams who want to use this data, they might be writing Hive queries, they might be writing pig scripts, or they are directly writing the MapReduce programs. But whatever it is, finally they gets converted into your MapReduce programs or essentially YARN applications, and they will be executing on your cluster. Now the problem comes is, if there are like lot of jobs coming to YARN to execute, so what will happen is the first one will come. If it starts taking all the resources, so all the people in the back has to wait. And for example, think that the first job which comes is a very big job, or it's a time-taking job. Okay. Now what will happen is all other jobs, even if they are smaller jobs, they will starve for the resources, they will not get the resources, and the person who has actually submitted that job will get frustrated, or he will not be able to do his business. His business will get affected, right? And in a typical organization where you have lot of departments and they are sharing the jobs, there should be a mechanism where actually they are given a good amount of resources for completing their task, and there should be a way to manage all these jobs in terms of resources. Okay, so for that Hadoop has a concept called job scheduler. So what does job scheduler will do is, whenever you submit a job, so it, based on the algorithm selected for job scheduler, it will try to follow some rules to actually run these jobs in some order by giving the resources by following some rules actually. So it all follows rules based on the algorithm you have selected. So so what will happen is, because users are sharing this cluster and they are submitting all the jobs, so there should be a mechanism to make sure that it provides a guaranteed capacity to the production jobs, as well as interactive good response time for interactive jobs. Like, that means actually smaller jobs should be able to complete fast. That doesn't mean that the longer jobs will keep on waiting. They should also be running, but at the same time, if the smaller job comes, it should have some chance to complete. Okay, it should not take, like, if the job is normally running for 5 minutes, but because the bigger job is running, which is running from 24 hours, this 5 minutes job should not take 24 hours 5 minutes. Okay, that doesn't look good, right? And it may hinder your business. So for that, actually we have two job schedulers. One job scheduler is called as capacity scheduler, and second one is called as fair scheduler. Okay, so I mean, there are so many job schedulers, but these are two popular schedulers which we will study. So the first one is capacity scheduler. So capacity scheduler is the first scheduler which introduced the concept of queues. So what will happen is, administrators will set up these queues, multiple queues. So there will be queue for every department, for suppose, and you can actually go and submit your job to a particular queue, and every queue will have a predefined capacity or configurable capacity. So everybody will be having different capacities. So based on the queue you have, you will be getting those the resources. Okay, so how can we create different queues? So you can go to your mapred.site XML, and inside that you can create these properties. One property is called as yarn.scheduler.capacity.root.queues. Okay, so by default the top level queue is called as root, and inside which actually you can create a hierarchy of queues. You can create A, B, C, and inside A you can create A1, A2. So this is exactly like your organization. Your organization is having top level is your organization. Then you have three departments, A, B, C, and inside department A you have team 1, team 2. So that's what it shows. So here you have root. Inside the root you have A, B, C. Inside A, okay, inside A you have A1, A2, and inside B you have B1, B2, B3. So your organization is root, and inside root you have three departments, A, B, C. Inside A department you have A1, A2 teams. So like that. So whoever is actually working in A2 team, they should submit their jobs to this queue. Other people should A2 people who are working in A2 team should submit here. Like people who are working in B3 should submit here. So that is how actually it is. It can be configured. So what we are doing is actually we are giving different capacities to all these queues, and when we submit our job to this particular queue, actually we are only using those capacities. But still the problem of if I am getting a very big job and a smaller job after that to the same queue called A1, so still my problem of not completing smaller job till the bigger job is completed is still there, right? So still that problem is there in capacity schedule, but we can make sure that all the departments are getting their own resources. these resources are actually allocated to different departments, and they are getting it because they are paying money for this cluster. So it's a combined money which comes actually. So to solve that problem, they came up with fair scheduler. Okay, so in fair scheduler, there are 3 rules to be followed. All the jobs are placed inside pools. I mean, these pools are like your queues only, and these pools are created based on username or Unix group, because what will happen in a company is you will be having LDAP. So based on the LDAP, I can understand to which department this person belongs to based on his username and group. Because normally what will happen is LDAP or any authorization system which is at an organizational level, okay, like LDAP, will create usernames on all the machines by the admins itself. So you can directly log in through that username and with the same password on different machines. Okay, that is called as actually LDAP kind of thing. So if you are using LDAP kind of thing, you have the same username, and your username also has a concept called group name. So this group name normally will be your department name. If you are from QA, you will be under QA group. If you are from analysis thing, so you will be as analyst. And if you are from data team, you will be a data group. So that is how they will create these groups. So based on these groups, your jobs will be put into different pools. Okay, he is not actually, we are not specifically telling to which queue we have to put, but it will be putting into different pools based on the Unix name, the Unix group name or username. And each pool, once you put into different pools, it's exactly like queues. There also you can get the same problem of having a big long running query, and you have a short running query, and still you have the same problem. So to eradicate that problem, what they are doing is they will give a guaranteed capacity, okay, to every job, and if they don't have any other jobs running, then they will give the other capacity also to this particular job. But once another job comes, so only this guaranteed capacity will be given to the existing job, and the other capacity will be taken and given to the new job. Okay, so it's like you have a fixed amount of resource for every job, but other resources, if they are free, they will be used. But if somebody comes in between and says, no, I need these resources, that will be taken from you and given to the other people. So this will help you in making sure that your shorter jobs will complete very fast. At the same time, longer jobs will not wait for all the shorter jobs to complete. Okay, because if you say, okay, first I will give the preference to shorter jobs, then first one short job comes, you are actually processing it, second one comes, so there is a big queue of short jobs and there is one long running job. So what will happen is, if you start prioritizing them based on the shorter job and longer job, so shorter jobs will keep on coming, then longer jobs will never get resources, it gets stuck. Okay, or in the reverse case, if you start a longer job, then if there are a lot of shorter jobs coming, so all of them should wait till the long job will come. Okay, so to remove this problem, what they have done is they come up with a concept called guaranteed capacity, and that means actually that is the fixed amount of resource which will be given for a job, and other resources, if they are free, that will be given. Otherwise, if somebody comes in between and says, no, I need those resources, that will be given to that particular job. Okay, so the benefit of using fair scheduler is all your longer jobs and shorter jobs can run, and longer jobs will be getting at least the guaranteed capacity, and shorter jobs will get the extra resources. Even if the longer job is running, that will be taken and given to the shorter job, so that shorter jobs will finish faster. So this is also easy to enable. So you have to put these properties into mapread.site.xml, yarn.scheduler.fair. So it's actually, this says fair scheduler, hello undeclared pools true, and user as default queue true, and file preemption is true. So if you put all these parameters and restart your MapReduce, So Yan resource manager daemon, then it is going to, because resource manager is the person who is actually understanding about this schedule. So you have to restart that process. Once you do that, it will start working with Fate scheduler. Okay. So that's all for this day.